Balancing a chemical equation by inspection. The third way of balancing a chemical equation is by inspection. We look at an unbalanced chemical equation of a reaction. Magnesium, solid, reacts with oxygen gas to give magnesium oxide solid. Mg solid plus O2 gas giving MgO solid. We see that there are two oxygen atoms in the oxygen molecule O2 on the reactant side of the equation. On the other side, we note a single oxygen atom in the magnesium oxide formula unit. To increase the number of oxygen atoms on the product side, we write another magnesium oxide formula unit on the product side. The equation will now become Mg solid plus O2 gas giving MgO solid plus MgO solid. This equation is still not balanced because we now have two magnesium atoms on the product side but only one Mg atom on the reactant side of the equation. So, we add one Mg atom to the left and get Mg solid plus Mg solid plus O2 gas giving MgO solid plus MgO solid. Now the number of atoms on both sides of the equation are equal for each element. The equation can be written as 2Mg solid plus O2 gas giving 2MgO solid. Here the two Mg atoms are represented by the 2 in front of the chemical formula for magnesium. The number 1 in front of the O2 molecule is not written, but is assumed to be there. These numbers are called stoichiometric coefficients. This is the balanced chemical equation for the reaction. Let us take a more complex example to understand this method better. Sucrose reacts with oxygen to give water and carbon dioxide. C12H22O11 solid plus O2 gas giving H2O liquid plus CO2 gas. Let us count the number of atoms of each element on the reactant side and on the product's side. Reactant side: carbon, 12 atoms; hydrogen, 22 atoms; oxygen, 13 atoms. Product side: carbon, 1 atom; hydrogen, 2 atoms; oxygen, 3 atoms. Let us balance the equation. C12H22O11 solid plus O2 gas giving H2O liquid plus CO2 gas. We can start with carbon, as it features only once on either side of the equation. So, we change the coefficient of carbon dioxide on the product side to 12. In other words, there are 12 molecules of carbon dioxide formed. The equation now becomes C12H22O11 solid plus O2 gas giving H2O liquid plus 12 CO2 gas. Reactant side: carbon, 12 atoms; hydrogen, 22 atoms; oxygen, 13 atoms. Product side: carbon, 12 atoms; hydrogen, 2 atoms; oxygen, 25 atoms. We now attempt to balance the number of hydrogen atoms. Hydrogen also features only once on either side of the equation. We change the coefficient of H2O on the product side to 11. Noting that there are 2 hydrogen atoms in H2O. The equation now becomes C12H22O11 solid plus O2 gas giving 11 H2O liquid plus 12 CO2 gas. Reactant side: carbon, 12 atoms; hydrogen, 22 atoms; oxygen, 13 atoms. Product side: carbon, 12 atoms; hydrogen, 22 atoms; oxygen, 35 atoms. Finally, we balance the number of oxygen atoms. This is because oxygen features in all the 4 chemical substances in the equation. We change the coefficient of O2 on the reactant side to 12. The resulting equation is a balanced equation. C12H22O11 solid plus 12 O2 gas giving 11 H2O liquid plus 12 CO2 gas. Reactant side: carbon, 12 atoms; hydrogen, 22 atoms; oxygen, 35 atoms. Product side: carbon, 12 atoms; hydrogen, 22 atoms; oxygen, 35 atoms.
Starting to feel it? Now go master it with